Hi everybody, it's Tyler here at Riverbots, checking in with VEXU team BLRS, coming in from Purdue University. This is an incredible set of machines that we have here. Ball transmission, which I'm really excited to talk more about, the implementation of that, but a lot of great custom work. Also last year, winners at Nuketown as well too, so congratulations on that. Quarterfinalists at Worlds, looking for big things here at Riverbots, I'm sure as well too. We'll be going all the way through this robot, talking about some of their different match strategies that they're doing as well too, and implementations to the Lady Brawn you'll keep an eye out for, and a lot of other great stuff as well. Let's learn more about them coming up here on Pits and Parts. Taylor, let's take a look at this ball transmission here. I love, first off, why did you even go this route in the first place, and then break down how it works for me.
Okay, so last season we were running a 10-motor drive at a very high RPM. We figure out it's very fast and efficient, but when encountering defense, especially more and more teams in VEXU are putting more motors on the drive, we still struggle at defense. So this season we will like our chassis to be pro on both cycle speed and defense. So as you can see, our drivetrain has a 6-wheel setup, and we have 2 main drive gearbox with 5 motor on each side. And as you can see, these 2 pancake pistons are powering the main shifter on our output shaft on each gearbox. So that allows us to shift from maximum speed to maximum torque, and our maximum torque is about half the speed of our max speed, so that allows us to tie and even push over most of the robots in VEXU. Also, another unique point for this drivetrain is I think we're the only few teams that's using all timing belt to power our wheels. So we do this because we want very it gives us very little gear slop between the wheels, so it makes our drive more consistent, and it also accelerates faster, and we never had issues with breaking gears or stuff like that.
In terms of the ball transmission, go ahead and show that off. Were there any challenges in terms of packaging it or testing it or anything like that that you experienced?
Need to try. Okay, yeah, we did face a lot of challenges doing this. Okay, so because we studied the design from many other competitions such as FTC and FRC while designing this gearbox, and the main difficulties is to reduce friction while still keep a very small gear slop. Also, we need to have the perfect air pressure for the shifter so it can shift fast enough but also not creating too much friction to the drive.
Very cool. Grayson, let's talk about, as we go through on this robot here, your intake that you're utilizing it. I noticed the timing belt, the intake as you go up through as well. Talk to me more about the design.
Yeah, so our intake starts down here at the opening, so it deploys from a closed position, and then it can also retract so that we can perform in our auton, so that we can grab these stacks of 2 or whatever over in the start. And then our center point here actually floats so that we can avoid jams when it gets into the timing belt area. So once it gets through here, it moves into our timing belt, which we used chain initially, but that started having issues snapping, and we had just overall some bad tension issues. And then right here in the middle, we actually have a vision system that we'll talk about later in the code that detects colors and can automatically spit different red or blue rings. So we'll run it right now. Yeah, that's about it.
So definitely flips in there. I noticed you have the guides in the front here too for the mobile goal as well.
Yeah.
What other designs did you consider instead of running this route?
Yeah, so we considered a couple different lifts, like just an overall wheel that runs everything up, but really we decided early on in season that this system of the chain lift was the way to go. And so the timing belt just moved up from there as a better way to perform.
Wes, let's talk about your mogul mech that you have on here. You got the nice curve on this as well too. Big fan of that as well in terms of securing that. So walk me through just how that works.
Yeah, so obviously every team needs a mogo lift. The mogo lift is really important for a lot of things during the match. And the first thing you want to have is a very solid clamp. And this clamp experiences a lot of leverage from the long goal hanging back here, so it needs to be solid. So you can see we have our main support for this is actually made out of a high-strength shaft that we drilled holes in. And we had to make a couple runs at this because we want to make sure that this geometry is identical on both sides. You see we have 2 pistons here that power a near over-center mechanism. An over-center mechanism allows you to close it, and the geometry keeps it closed without requiring too much active power from the pistons. So here, I can sort of show you that here. See, this pushes all the way in to where when I pull up on this linkage that's powered by the piston doesn't really experience any force. So if you let go of it for me, Nathan. If we look down here again, we have some curved standoffs that we bent because these really, the angle that the goal is held is really important, how it's positioned up here, and we found after a lot of trial and error that this was the ideal method. So we also have some hard stops to make sure our over-center mechanism doesn't over-center too hard and i.e. become unable to actuate. And we also have some stuff like these bar locks here and here to help increase the rigidity of the mechanism because, like I said earlier, it experiences a lot of leverage and force on it during the match itself.
Let's move on to your Lady Brown mechanism. Matt's going to cover more about that, but not just Lady Brown, but you've done a couple cool customizations to this. Really more in terms of the length and the challenges behind that, right? So I'd love to hear more about how you tackle that.
Yeah, so through a lot of preliminary testing with different geometries and different styles of lifts for these rings, we kind of found that the Lady Brown mech was a lot more consistent. However, in VEXU, we have different size constraints. We have a 24-inch robot and a 15-inch robot. And with the 15-inch robot, we're really limited on, how our higher starting position is, how long this limb can be relative to where our intake sits. So we had to do some additional things to really increase the length of the drivability of our robot to make scoring wall stakes as easy as possible. The first of these changes is this lever arm right here. So if we have a ring in our Lady Brown mechanism, as the Lady Brown mechanism goes up and rotates over to the wall stake, this lever arm is pulled so it pushes the ring out, getting just a couple more inches of extension just to further increase that drivability and ease of scoring in, high stress situations. It also makes our autons more consistent.
And then here, how does, we discussed before, you have kind of this fold down here that works for that too. Talk to me more about that.
Yeah, so again, with that size constraint, we started first here with our 24-inch robot and found a geometry that we really liked. But once we kind of decided that we wanted to transfer that over to the 15-inch robot, we found we were just a tiny bit out of size. So in order to combat that issue, maintain the same geometry, and start the match in size, we have these two pistons here and here that it'll pop the Lady Brown mechanism up. And that way we can ensure that we get that proper geometry that we had already thoroughly tested.
Jack, on your two, let's talk more about the software aspects of the robot too. I noticed that your odometry pods are angled at 45s as well too, so I'd love to hear more about just decision making behind that and just how all the software comes together in your robot.
Yeah, we can start with those odometry pods. The reason we decided to have 2 as opposed to 3 is just space limitations here. We had a lot of lateral space, but we weren't comfortable with the space we had here, especially vertically with some of the intake motors, fitting 3 odometry wheels, which is my preference as a programmer. But with 2, I feel like the best orientation is 45 degrees, and the reason for that with a tank drive is with your standard forward and horizontal tracking pod orientation, you typically only have one wheel tracking most of your motion on a tank drive like this, and the other wheel almost is never being used, only if you're drifting on an arc turn. This improves your accuracy and consistency and decreases your noise because you're averaging the value of 2 sensors for almost all straightforward movements, which has led to a significant increase in consistency. Our autons have been shockingly consistent today, considering the fact that we started programming them last night, and I think that that's mostly due to the odometry that we spent a long time tuning before we got to the actual code. And it's the same idea. We have 2 IMUs in here actually, kind of on top of each other. They're inverted. The idea is that if they drift, because the VEX IMU is not the best IMU, if they're inverted, the drift will be opposite and cancel each other out. So we just take the average, and that has also been a lot more consistent than one IMU.
By the way, not starting last night, but finishing when?
Oh, finishing, not finished yet.
Oh, still ongoing.
One robot is like 95% there, and this robot is maybe 40% of the way there.
Yeah, so you guys are on just a little bit of sleep from last night then, huh?
Maybe closer to 0.
All right, well, perfect. So, hey, you're doing pretty darn good then.
We made it.
0 sleep for sure. What else from software side do you want to cover?
Okay, so beyond the position tracking stuff, the other cool software aspects of this robot are the lift control software and the color sorting. And they're intertwined. So I can start with the lift control software. We have 3 macro positions. The bottom is stow, the next is load, and the top is score. We depressurized that already. Thanks. Those 3 macro positions make it really easy for our drivers to control. This lift and not have to think about getting it perfect every time. Nathan and Evan are great drivers, but they typically hate automation, so convincing them to try this was difficult. But considering how fast this reduction is on a green motor with a speed-up reduction, they were not able to consistently control it. And once we added this PID and got it tuned, they really liked it. However, this arm is also useful for tipping and untipping mobile goals, and we can also use it to put the Alliance stake on, for which we use manual control. If Nathan hits both buttons at the same time, the controller vibrates and enters manual mode, in which he can feather it with direct voltage control. And if he presses them both again, it'll go back into smart macro mode and go to the nearest macro wherever he was when he goes back into manual mode. That ties in with color sorting, which is this optical sensor right down here. We've had problems with the LED on it overheating, so the LED only turns on when there's a ring near it. And if we are on the red team and sees a blue ring, it will stop these hooks and jam the motor backwards for about 1/10 of a second right when it's at the top, which causes this ring to miss like this instead of flinging down like the correct color ring would. The other cool wrinkle we got to do with this recently is what I'm calling the wall stake dodge. Say we were on the blue team in Auton and we picked up a red ring by accident when we meant to load the wall stake. What the color sorting lets us do is if it sees the wrong color ring, it will dodge this down and then spit that and then bring it all back up, all with the Auton just saying intake or the driver just holding the intake button. Like that, he just did it.
Spend just a couple minutes here as we start to wrap up talking about game strategy and driver strategy. So, Nathan, starting with you on here, we just heard that you prefer more manual control over the automation on it, but just walk me through a little bit how game strategy works, and then we're going to be passing over to Evan as well to talk a little bit more about that.
Yeah, so generally speaking, whenever in the past, me and Evan, we were on a high school team together, and whenever someone made something automated, it usually wasn't very good. So we had a bad habit of saying, oh, anything automated is bad. But Jack over here, he's a really good, really talented programmer, and he's slowly changing our minds on what we think is good and not. But on the game strategy, the way that we kind of broke this game down is if we have 3 goals at the end of Auton or at the start of driver around that period, as long as we play smart and keep control of at least one positive zone, we don't really have to worry about losing. As long as we play smart, we don't give up our positive zone, and we don't let go possession of a goal. And as long as we win auto, there really isn't much the enemy team can do in terms of making the differential back. So if we win auto, great. That's our main plan. We'll stick to it. Now, if we lose auto, things get a little bit tricky, right? So we either have to start scoring wall stakes to try and pressure the enemies out of their positive corner, or we have to go in with the 24 that has a goal rush arm and try and grab the enemies their positive goal. And so it really, every match is different. This game it's pretty simple, but it's also very variable. It changes every single match with how you play. And this is our first tournament, and me and Evan, we've driven for 5+ years, and we still are confused on how to drive this game.
Sure.
So it really is. It's a pretty simple game on the surface, but once you get into the higher levels of play, it can get very, very complicated very fast.
Evan, anything else to add on to that?
Yeah, to kind of sum up some things, I would like to kind of talk about how these mechanisms are actually helping with the strategy, how we're using things like the transmission to keep 3 goals or take one from an enemy team, such as if an enemy team has 3 goals, we can go over, grab with our over center mobile goal lift and use the transmission to drag them out of their positive zone, forcing them to either let go of that mobile goal or letting us get behind them and steal from their positive zone. Another thing is, like Jack said, we don't like automation, so we've also made a lot of changes where if automation breaks, he's given us buttons to override any of the automation and make everything manual. So we've come to the conclusion of if Jack's stuff doesn't work, even though it normally does, we still have the control for ourselves, and it's made it very nice, and it's made us work together very well because we can accept every idea instead of me and Nathan doing what we used to do and shut each other out and just say, no, we don't want change, we want to control everything ourselves. We've been able to work together as a team and actually come together and create 2 robots and work together really well.
Overall, working out great for you so far. BLRS, thank you so much for taking time to break down these incredible machines and your match strategy as well too. One of the most long-standing teams in VEXU as well, so very excited to see your continued success that you've had so far. Good luck here at Riverbots, and of course throughout the rest of the season. Thanks a lot, guys.
Thank you.